Solving equations with squares and cubes involves simply a new operation. Just like you can add, subtract, multiply, or divide anything you want as long as you do it to both sides of an equation, those are called the properties of equality. You can do the same thing with squares, square roots, cubes, and cube roots. So with that in mind, let's look at solving an equation like a squared equals 100. Well, if our goal is to isolate the variable a, then we need to get rid of the square, and the inverse operation for squaring is in blue, square roots. Now, the square root and the square will cancel out, and we'll get a is, now you want two numbers that multiply together to give you 100, and those two numbers are going to be positive 10 or negative 10. So one way to write this answer is a equals 10 or negative 10. You could, of course, reverse them. That wouldn't make any difference. And a really common way to write them, more so than this, is to just write plus or minus 10. That's probably the easiest way to write them and the most concise. So with that in mind, let's move over to a cubic root. Now, cubic root, same exact concept. We have a b that we want to isolate. It has a cube on it, so we're going to do the cubic root. But if we do it to one side, we have to do it to the other. The cubic root and the cube will cancel out, so we end up with b equals, and what number times itself equals 27, and that number is 3. For cubic roots, you do not have the positive and negative version because negative times negative times negative would be negative. So b equals 3. Now, with that basic concept in mind, we can extend that to other kinds of equations, right? Here we go. C squared plus 10 is 37. Well, we have to isolate the c, which means get rid of 10, so we don't lose those skills that we had before. We simply add the square root option. Now, in this one, the square root of 27, I'm going to go to my calculator. The square root of 27 appears to be about 5.2. So I'm going to say plus or minus 5.2. All right, that's an approximate answer, by the way. When we say approximate answers, teachers appreciate if you do the squiggle for approximate. I have another one down here for squares while we're on it. So same exact idea. We want to isolate the e, so minus 1 to both sides. We're going to divide both sides by negative 3 to isolate e squared. This looks like an 81. We're going to go ahead and square root both sides to get rid of the square, and e is plus or minus 9, right? So same concept as before. You're simply doing something to one side if you're doing it to the other. Let's jump back over to cubes for 2 more examples and be done. We want to isolate the d, so let's get rid of the coefficient 2. And for cubes, we do cubic root, indicated with the little 3 in the diving board. We're going to get d is, well, what times itself is negative 125. It's got to be negative and 5. And the last one, right? A little bit more complex, but one more time, same concept. Let's go ahead and get rid of the constant. We're going to go ahead and get rid of the divided by 5 by multiplying both sides by 5. And I'm going to go ahead and use the cubic root of both. Let's move this over a teeny tiny, oops. Let's move this over. Cubic root, and I get f equals, and again, don't know what the exact answer is. By the way, if you watched this far, you could say f equals the cubic root of 25. That would be the exact answer. The approximate answer I get with my calculator, 2.92. And that is how you solve equations involving squares and cubes.